The graph of the function y equals f of x is shown below. On which of the following intervals is f prime of x greater than 0 and f double prime of x greater than 0? If f prime of x is positive, that implies that is increasing function. Okay, increasing function. It doesn't matter what it looks like as it's increasing, as long as it's going up and to the right, it's increasing. If f double prime is greater than 0, that implies that it's concave up. So I need both. I need a part that's both concave up and increasing. I think the easiest thing to do first is maybe find the concave up part, so maybe I'll do that, and that appears to be happening between A and C, so you are concave up right here in that nice big purple, oh boy, purple line. And while that's concave up, it's also increasing between just B and C, right? So where that's happening with both is going to be in between, but not including B and C. So ignore the brackets here. We'll quick turn them into parentheses so no one screams at me in the comments, which no one really does anyway. They just gently tell me where I went wrong. So only between B and C. So between C and D, no. Between A and B, no. Between B and C, yup. And so we're going to say 3 only for that guy. Okay, that's where I want both of those things to occur, and both of those things occur only in between B and C. Dunzo. An equation of the line tangent to the graph of f of x equals 2x cubed minus 3x squared at its point of inflection is which of these? Ugh. All right, so what we have to do first is we have to find the point of inflection. And the way you find the point of inflection is you find out when f double prime of x is equal to 0. So let's find out what f double prime is. First, we have to find out what f single prime is, so let's get rid of you. F single prime of x is going to equal, drop down to 3, 6x squared, drop down to 2, minus 6x, that's f single prime. F double prime is going to be the derivative of that, and that's going to happen at 12x minus 6. All right, so set it equal to 0. 0 equals 12x minus 6. Let's add 6 to both sides. That gets me 6 equals 12x. Divide by 12, divide by 12. And the point of inflection occurs at x equals 1/2. Now, in order for me to come up with an equation of anything, right, I need a point and I need a slope. I have half a point. So the way I find the other half a point is I take that 1/2, I plug it into the original function, and that'll give me the f of x or the y value of the other half a point. So I need to find out what f of 1/2 is. So f of 1/2 is going to be 2 times 1/2 to the third minus 3 times 1/2 squared. Okay. Let me see. So that's going to be f of 1/2. My y value is going to be 2 times a half times a half times a half is 1/8. Minus 3 times a half is a fourth. That simplifies out to 2 times 1/8 is a quarter. Minus 3/4 is going to be negative 2/4, which is negative a half. So we have a point, and that point is 1/2, negative 1/2. Now I have a point. What I don't have is a slope. The way I find my slope of the tangent line is I take my derivative and plug in that 1/2. So here was my derivative, so let me bring that down over here. Let's plug 1/2 into that. So f prime of 1/2 is going to be 6 times 1/2 squared minus 6 times 1/2. Okay, that's going to be my derivative at the x value 1/2. That will give me 6 times a quarter, because a half squared is a quarter, minus 3. That will get me So 3, 6/4 minus 3 is 3/2 minus 3, which is negative 3/2. So negative 1.5. Ugh. So that's my slope. So I guess what I'll do is I'll plug this into point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1, and I'll turn that into standard form, which is what they want. So, what color didn't I use yet? Green. Y minus, you're my y sub 1, so minus negative means plus a half, equals m is negative 3/2 times the quantity x minus x sub 1, which is minus a half. Let's distribute that to give me, and I'm just going to write left to right, I guess. Y plus a half equals negative 3/2x plus 3/4. Ugh. Boy, I don't like that at all. What I'm going to do is I'm going to add 3/2 to both sides. So I'm going to put 3/2x rather, plus y to both sides, right? I'm going to subtract a half here, which gives me a quarter. And they want all constants here, so if I multiply everything by 4, that gets rid of all fractions. So 4 times 3/2 is going to be 6x plus 4y equals 1. Tricky, tricky, tricky. Kind of tough. Didn't like it. The graph of y equals f of x is shown below. If f is twice differentiable, which of the following is true? Well, it's giving me information about what f of x is, what f prime of x is, and what f double prime of x is. F of x tells me where it is above or below the x-axis, right? So let's say that is part 1. Part 2, the derivative tells me if it's positive or negative, whether it's increasing or decreasing. Why I abbreviated increasing but not decreasing, don't ask. This guy is telling me the second derivative, whether it's concave up or concave down. So it won't abbreviate. Well, I did abbreviate both of those. Now let's find out what we have in blue first. This is above the x-axis, right? The whole thing. So we know that f of x is going to be above the x-axis, so f of x is positive, which eliminates u. Now, this whole function is going down and to the right, which means it's decreasing, which means f prime of x is less than 0. Okay, which eliminates u and eliminates u. This function is concave up, which means f double prime is positive, which eliminates u and gives me u. So B is going to be my answer for that one. Fun stuff.